Well, this should be the last video for spring term. We're going to go over the problems on this handout where we use the Maclaurin series for sine x, cosine x, and e to the x to do integrals that can't really be integrated any other way. So let's see here. Let's put our Maclaurin series up here. So we've got e to the x, 1 plus x squared over 2 factorial, x cubed over 3 factorial, and so on. Okay. Sine function, this is the odd function, and it's an alternating series. And then the cosine function is the even function, which is also an alternating series. That should be plus there. Okay. So there are the series that we're working with. Let's look at problem 4 here. So problem 4, we want the integral from 0 to 1 cosine x cubed. Okay. So what we want to do is, if this is cosine x, then cosine for x cubed is going to be the same series, but with an x cubed plugged in for all the x's. Okay? So we're going to get, let's see here, 1 minus x to the 6th over 2 factorial, x to the 12th over 4 factorial, 18th, and so on. Okay, if we need more terms, we can go back and just continue to follow this pattern. So, if we want to integrate this, then we need to integrate this series. 1 minus x to the 6th over 2, x to the 12th over 4, factorial, x to the 18th over 6 factorial, and so on. The next one would be x to the 24th over 8 factorial, dot, dot, dot. Okay, so let's do the integration. This will be x, and then x to the 7th over 7 times 2, x to the 13th over 13 times 4 factorial, 19th over 19 times 6 factorial, and I'll put this last one on there, but this one probably won't make any difference if we're rounding to 3 decimal places, okay? So, and then we want to evaluate this from 0 to 1, so this is 1 minus 1 over 14 plus 1 over 13 times 4 factorial, 1 over 19 times 6 factorial, and so on. Okay, so now I'll start out with just these first 2 terms. Let's see here, 1 minus 1 over 14, and that comes out to about 0.928 or so. And then let's add the next term, or let me put this on here. 9, 2, 8, 5, 7. And then we're going to add on 1 divided by parentheses, 13 times 4 factorial, 0.93177. And then subtract 1 divided by parentheses, 19 times 6 factorial, 0.93170. And so this is what I was saying. I can add this last one on here, 1 divided by parentheses 25 times 8 factorial, and it's still 0.99317 or so. Okay. So, to 3 decimal places, this would be approximately 0.932. And I'll show you the screen where I was making those approximations here. All right, let's see here. There we go. And the goal is, if you're rounding to the third decimal place, you just want to get a sense of what that third decimal place is going to be. And you probably should get the fourth place to settle down as well so that you know how to round it, whether it's going to round up or round down. Okay. That's problem 4. And notice that in this problem, and I'll talk about this more, this was a substitution problem, okay? What was happening inside the cosine function, and so then I had to substitute that piece into the series. So some of these are a little bit different. Yeah, problem 6 is a good example of something that's not a substitution problem. So problem 6, we've got the integral of square root x times sine x. Okay, so notice that in the sine function we just have an x here, and so we're just using that series right there. So rather than a substitution, this is a multiplication. So what we've got here is x to the 0.5 times the sine of x. So we'll take x to the 0.5 times the series for the sine function. And so then we'll come out of this with x to the 1.5, x to the 3.5 over 3 factorial, 5.5 over 5 factorial, whoops, minus 7.5 over 7 factorial, and so on. We can come back and get more terms if we need more accuracy. This should probably be enough for us. So now we're going to integrate this series, which represents this quantity right here. 5.5, 7.5, dot, dot, dot. So our integral here is going to be x to the 2.5 over 2.5. And then x to the 4.5 over 4.5 times 3 factorial, 6.5, 6.5 times 5 factorial, 8.5, 8.5 times 7 factorial, okay? And then dot, dot, dot. We probably won't have to go too far past that to get this to round to 3 decimal places. Okay. So let's, and then if we plug the 1 in here, 1 over 2.5, and so on. And so this is what we want to calculate with and kind of see when that third decimal place settles down. So 1 divided by 2.5 minus 1 over 4.5 times 3 factorial, which is 6, and that'll give us 0.36296. And then we'll add on 1 divided by parentheses 6.5 times 5 factorial, 36424. And then subtract 1 divided by parentheses 8.5 times 7 factorial, 0.3642. And so there it is, right? We've got those first 3 digits. The thousandths place is settled down. The 10,000ths place hasn't changed either, so we know it's going to round down to 0.364. And in most cases, you can double check these on the calculator. If you put this in your f of x in the y equals section, and then you can choose that integration from the calculate menu, which is choice number 7. So if you have questions about that, please let me know. But there's a variety of ways that you can check these out using technology. They're not always as accurate as I found. Let's see, which problem was that? I think it's the next one, problem 8, where I got a more accurate answer by doing this than I did from the graphing calculator and also the graph software. I tried both of those, and they both gave me something that rounded to 3 places correctly, but was actually not all that accurate. I went to Wolfram Alpha and double check my work on Wolfram Alpha. And so I'm not sure what's going on, why the graphing calculator and the graph software are a little bit off. But so that's just to say, you know, if you get something that's a little bit different from your work from one of the pieces of technology, it may mean that you're wrong, it may not mean that you're wrong. So that's sort of the issue whenever you're checking your work against something else. Okay, well, let's take a look at problem 8 then. Problem 8 is similar to number 6 in that it is a multiplication problem rather than a substitution problem. And so it starts out like this, cosine x over square root x. And so I'm going to call this x to the minus 0.5 times cosine x. Okay, so if we do that, then we'll do x to the minus 0.5 times the cosine series, 1 minus x squared over 2 factorial, and so on. And if we multiply through there, x to the minus 0.5, x to the 1.5, 3.5, and so on. So that's what we need to integrate. X to the minus 0.5, and then 3.5, 5.5, 7.5. So now if we integrate, we'll get x to the positive 0.5 over positive 0.5, and then x to the 2.5 over 2.5 times 2, and then x to the 4.5 over 4.5 times 4 factorial, 6.5 times 6 factorial, and then 8.5 times 8 factorial. And that should be plenty of terms to give us an accuracy to the third decimal place. So here are the fractions that we need to calculate with 4 factorial. There we go. And again, if we need more terms, we can just generate them. This is actually a pretty simple pattern, right? The next one would be 1 over 10.5 times 10 factorial, 12.5 times 12 factorial, and so on. Well, let's just go ahead and calculate what we've got so far here. Okay, so 1 divided by 0.5 minus 1 divided by parentheses 2.5 times 2. And so that starts us out with 1.8. And then the next part, plus 1 divided by parentheses 4.5 times 4 factorial, 1.80925. And then minus 1 over parentheses 6.5 times 6 factorial, 1.80904. And you can see the third decimal place isn't changing between these two. Okay? And this went from 2 down to 0. I'll go ahead and add on that last term. 8 factorial, 809,048. Yeah, and this was a 4-5, okay? All right, so this is going to be approximately 1.809. And if you do this on the calculator using that feature, it does round to 809, but they keep giving me the 1.8085 value, which is just not correct and doesn't even show up here. So I really kind of have a question as to how they're calculating that integral. So here's the sum of that series. I was doing term by term there. Another good way to do these, if you have a computer in front of you is to do it with spreadsheets. I'm a big fan of using spreadsheets for series, right? So each of the terms would be a number in the spreadsheet, and then you can just put a formula in and it'll calculate based on that. And that saves a lot of work. Okay, that's problem 8. All right, let's look at one more here. Problem 12 is another substitution problem. And this is the integral from 0 to 1 of e to the x squared dx. Okay, and so like I said, this is a substitution problem. So e to the x squared is going to be 1 plus x squared plus x squared squared over 2 factorial, x squared cubed over 3 factorial, and so on. And so this will be 1 plus x squared, x to the 4th over 2 factorial, x to the 6th over 3 factorial, and so on. So this is what we want to integrate. Okay, all right, so let's do the integral. X cubed, not 1, but x. X cubed over 3, and then x to the 5th over 5 times 2 factorial, x to the 7th over 7 times 3 factorial, 9th over 9 times 4 factorial, dot, dot, dot. And then if we need more terms, we can just keep going with that. It'll be x to the 11th over 11 times 5 factorial, and so on. All right, so now if we plug in the 1 here, I've been just ignoring this 0 here, because if you plug the 0 in on any one of these, you're just going to get 0 out of it. Okay, so let's see here. This one is 1 over 5 times 2 factorial, which is really just 1/10. And then these terms start to get pretty darn small. I'll go ahead and put this one in there just for the heck of it. And now let's go ahead. So this is going to be 1.3 repeating right there. Let's see. 1 plus 1/3, and then plus 1 over 5 times 2, plus 1 divided by parentheses, 7 times 3 factorial, 1.457. Let's see, this is 1.43 repeating, and then 1.457, and then we'll add on that 1 divided by parentheses, 9 times 4 factorial, 46177. 46177, and let's see if I add this last one on there. Actually, I'm glad I wrote it down. 1.4625. And let's see, let's keep going here. 13 times 6 factorial, and then 15, where are we? 2, 3, 4, 5, 6 times 7 factorial. Okay, so plus 1 divided by parentheses, 13 times 6 factorial, 1.4626. And it looks like this is going to round to 1.463. I'll go ahead and add on this last term here, 1.4626. So if we're going to round this, it'll be 1.463 to 3 decimal places. Okay, so that's the last topic. I'll get a quiz up for this. And then, let's see here, today's Thursday. So next week, these quizzes are due next Wednesday. June 3rd, and then on the 3rd, I'll send out the take-home final, and then that'll be due a week from the 3rd, Wednesday, June 10th, and then that'll give me time to get everything collected and get the grading done and turn in those grades the following Monday. So, as always, if you have any questions, please let me know, and good luck. Thanks.